Okay, let's get right into adding some fractions. So what I'm going to do is I'm going to show you, let's add 1/3 plus 1/3 and see what our answer is going to get, okay? Remember, when we're dealing with fractions, ladies and gentlemen, I can't stress this enough that we don't get freaked out by what a fraction is. All a fraction is it's a relationship between a part over a whole, where our part is going to be our selected part of the fraction and whole is going to be the number of parts that it takes to make a whole. So you can see here I have a whole figure broken up into 3 separate parts. The part I'm worried about or concerned with is going to be 1. So I have 1 part over 3 because it takes 3 parts to make a whole, plus another 1/3. So remember, when we're adding fractions, all we simply do is the parts remain the same. Okay, the number of parts it takes to make whole does not change. That's why 1/3 plus 1/3, you don't add the denominators. We don't have 6 parts now. We only have 3 parts still. So 1/3 plus 1/3 is now going to be equal to 2/3. And you can see that by we have 2 parts over our third. Now, I'm going to do the rest of the fractions without any help really from you making some pictures for you, okay? So if we go ahead and take a look at here, we notice that we have the same denominator, which is good. And really, all we need to make sure we do is just add 5 plus 2 is going to give us 7/8. Because really, guys, if you look at all it did when they have the same denominator, all you need to make sure you do is just take your 2 parts and just pretty much like stack them on top of each other, because what your fraction is broken down to is always going to be what your denominator is, since those are the same. Okay, so now let's look at next one. Oops. 3/7 plus 6/7. Now this is going to be a special case where we still need to add our top and bottom. So now we're going to get 9/7. And you might say, well, how can you have a part that's greater than what your whole is? Well, all this simply is, without really trying to make some extra fractions, all I'm really doing is adding extra parts. So, really what this represents is, let's kind of try to do my best here. 1, 2, 3, 1, 2, 3, 4. So 1, 2, 3. I don't know. 1, 2, 3, 4, 5, 6, 7. Okay. This is a bar broken up into 7 parts, right? 1, 2, 3, 4, 5, 6, 7. So if I say I have 9/7, sorry, you guys can't see that. If I say I have 9/7, I have all 7 of these plus an extra 3 more. Now, it only takes 7/7 to make a whole, but I have an extra 3 of them right here. So you can have fractions that are going to go above your part. Lastly, oops, I don't want to do this one. I wrote what the answer was. If I have 5/12 plus 1/12, my answer is going to give me 6/12. And it's just important, guys, for you to understand that whenever you have a fraction, you always want to reduce it. So I can say 6/12, I can reduce this down to 1/2. And I did that by saying what number divides evenly into 6 and into 12. And that answer is 6. So 6 divided by 6 is 1, and 12 divided by 6 is 2. So, ladies and gentlemen, that is a quick little tutorial on adding fractions with, like, denominators.